Okay, we're going to look at some more examples involving implicit differentiation. So we'll start off easy here. And what I want to remind you of is that implicit differentiation is just the chain rule, glorified version of the chain rule. Here's what I mean by that. I mean that there's really another function inside of y here that contain a bunch of x's. I don't know what those x's look like. It could be the square root of x squared minus 4x or something. We have no idea. But what we know is that y is a function of x. Okay, so if I were to differentiate this thing then with respect to those x's, okay, the derivative of this equation with respect to x. Well, as long as this little variable here and this little variable match up, then you can go ahead and take the derivative the way you always have. Okay, so what's the derivative of x with respect to x? Well, it's just 1. And let's do the other easy one. The other easy one is the derivative of 4 with respect to x, and we know that that's just 0. Okay, but when we get to the derivative of y squared, okay, this variable and this variable aren't the same, and so what we have to do is we have to use the chain rule. Okay, so the chain rule says take the derivative of the outside function. Well, what's the derivative of the outside function? It is just 2y. Okay, but the chain rule says once you've taken the derivative of the outside function, to go inside where all these x's are and take the derivative of that function. Well, I don't know what that function actually is, so we just have to call it dy dx. Okay, this is the derivative of y with respect to x. So just to be clear, derivative of the outside function is 2y multiplied by the derivative of the inside function. Okay, the only thing left to do is to isolate your dy dx and solve for it. And this is just algebra at this point. So we get negative 1 on the right hand side, and then let's go up here and we get dy dx equals, now I'm just going to divide both sides by 2y, and I get negative 1 over 2y. Now you'll notice that this function is strictly in terms of y, and that's okay. This is the derivative of this function up here. If you look carefully at this thing, this is going to be a parabola that opens sideways. Okay, so let's look at another example, a slightly more complicated one. And here it is. Let's do y cubed plus y squared minus 5y minus x squared, and all of this equals 3. How's that? Okay, so a little bit more complicated. I have no idea what this graph looks like. You could graph it. I would hate to do it by hand. I suppose a computer program could do it fairly easily, like Maple or Mathematica or something. But it doesn't matter. We can differentiate it with ease, as long as you know the chain rule, as long as you keep track of your steps. So if I differentiate with respect to x, remember I'm looking for variables to match up. If they match up, I differentiate how I always do. If they don't match up, I have to use chain rule. So the derivative of y cubed with respect to x is the derivative of y cubed with respect to y, which is 3y squared, multiplied by the derivative of y with respect to x. I will use y primes in this example, but this is the same thing as dy dx, plus the derivative of y squared with respect to x. Well, that's going to be the derivative of y squared with respect to y, which is 2y, multiplied by the derivative of the function inside. Okay, so not to sound like a broken record, but the derivative of the outside function multiplied by the derivative of the inside function, minus, what's the derivative of negative 5y? Well, it's the derivative of negative 5y with respect to y is negative 5, multiplied by the derivative of the inside function. And finally, we get an easy one. The derivative of x squared with respect to x is simply 2x. And this all equals 0. Okay, the last thing to do is to gather up all our y primes. So I have a y prime here, here, and here. So I'm going to factor that y prime out, and I'm going to move this guy to the other side. So let's do this. Factor a y prime out of your expression, and I get 3y squared plus 2y minus 5. And that all equals positive 2x. Well, you can guess that the last thing we will do is divide. And we get 3y squared plus 2y minus 5. And there you have it. We have a derivative of our original equation. And notice that it's another implicit equation. And that's okay. Okay, for the final example here, I've chosen a slightly more difficult one. And let's see here, it is x to the fourth plus x squared y squared minus y squared, and this all equals 0. Okay, so when I differentiate this thing with respect to x, I always step back and ask myself, are there any other rules that I'm going to need? And it turns out I'm going to need the product rule for that guy right there, because this is a product. Okay, so let's keep that in the back of our mind. Derivative of x to the fourth is 4x cubed. Now, I will do the derivatives in a separate color here. Just a minute. Okay, this is plus. Okay, so what's the derivative of my first function with respect to x? Well, it's just 2x multiplied by my second function, which is y squared, plus the derivative of my second function. Well, what's the derivative of y squared? It's just 2y y prime, and then I'm going to multiply that by my first function. So the parentheses are unnecessary, but I do that just to show you that this right here is the derivative of this guy right here. Okay, and then finally minus 2y y prime equals 0. All right, so the last thing to do is to gather all of your y primes to one side. And this should be x squared minus 2y y prime. And on the right-hand side, I should get a negative 4x cubed plus, no, not plus, minus 2x y squared. Okay, factor the y prime out, and I have 2yx squared minus 2y, and this equals negative 4x cubed minus 2xy squared. Almost done. Last step is to divide. Divide everything by this guy right here, and we get y prime is equal to negative 4x cubed minus 2xy squared all over 2y x squared minus 2y. Now that not probably, I know it does. I know that can simplify. Looks like we can factor a 2x out of the top and maybe a 2y down below, and some 2's might be able to cancel, but I'll leave the algebra and the simplifying up to you. But that is implicit differentiation in a nutshell. I hope that made sense. In the next video, I will try to attack a second derivative using implicit differentiation. See you there.